Hi everyone, welcome back to my channel. So, just as I told you on the Wednesday session, I'll be uploading all your doubts. Okay, so today I'm going to give a big shout out on all those who have asked me doubts, and also I'm going to share all my knowledge on those doubts that you have asked me. Okay, so I'm dividing this into two parts because basically I got the many doubts more than I expected. So that is why I'm going to segregate it into two parts, and in the first part, I'll be clearing some doubts which are most frequently asked to me. So this doubt was asked to me by Monica. What is it is what is the difference between task and function with example? Okay, she asked me in order to differentiate the task and function with an example. So don't worry about it. I'll explain it to you. So what I'm going to do today is I'm going to explain this to you with an real-time example so that it will be easily understood for you. Okay, so today I am going to take the SV test bench architecture in order to tell you the difference between tasks and functions. So in real time, what are you going to how are you going to differentiate the task and function? So if you see this here, okay, this is the function. If you see this is the transaction in the system Verilog. Okay, transaction is nothing but packets of data. So in this you are using a function. So where do you use the function? Basically, function is used where you don't use any delays. That means you are writing a particular subroutine which doesn't contain any delays, which doesn't contain any non-blocking assignments, and which doesn't contain any, which should at least return one value, or which should which doesn't contain the system task like dollar monitor and dollar strobe. Why dollar monitor and dollar strobe? Because you already know that dollar display and dollar write will be working in the active region. So you all know that function don't accept any delays or any waitings. So that is why we use dollar display and dollar write in functions, whereas dollar monitor and dollar strobe, those will be in the, what is it, it is active, inactive, nb and postpone. So dollar strobe and dollar monitor will be in the postponed region. So that is why when you want to use dollar strobe or dollar monitor, then you shouldn't use function but you should use a task. Okay, since function is having all these limitations, and when you are using a function, you should use a function where all these limitations doesn't exist. That means when you don't want to use any delay, if you see this particular function here, does this contain any delays? No. Or else does this contain any dollar stop dollar monitor system tasks? So no. And it contains at least one input like string name. Okay, so this is how you will be differentiating between where to use the task and where to use the function. For the same thing, if you see the particular example here, this is the generator block, and if you see the generator block here, I have used the task. Okay, so why I have used the task here? If you see, I am not mentioning any inputs for this. Okay, this main argument is not having any inputs or no outputs, which is not mostly allowed in case of function. Okay, this is one thing. And also if you see here, you are using dollar put. Okay, put means nothing but mailbox. So what is the active function of this dollar put in main box is it will be waiting until all the transactions are being putted. Okay, that means if this put is not filled, then that put is not going to activate. So that is what then what does it mean? That means it is in a waiting state, but function doesn't allow waiting states. So that is why you are using a task instead of function here. Okay, the same thing with driver also. If you see the in the driver also, you will be using the task itself. Okay, why? Because you are using a wait. Okay, wait, delay, so all these are not allowed in case of function. So that is why you will be using a task here. Here in the same thing, if you see task main, here also the same thing, put and get. That means put and get basically until all the transactions are being putted, and it has to wait. In the same way, until all the transactions are taken away from the generator, this get option should wait. That means this waiting since is not allowed in function, so we don't use this particular put and get here. Similarly for environment also, if you see here in the environment, here you are using a test. Okay, basically for because you are using like fork and join any, which are called as threads in system verilog. Okay, we'll be discussing that later. So because of all those things, we are using a task here. Got my point? Hope you got the difference between what is the function and what is the task. Okay, so this is why basically you will be having the difference between, this is the difference between function and task. Okay, so next, the second question is asked by Satvik, like how to improve my skills in SV and UVM to become a verification engineer. So this is a very frequently asked question to me. Not only a verification engineer, so basically when you enter into this industry, like when you are in a front end industry, you can be either facing a place in either in design or in verification or in simulation. So all these three will be in one go. Okay, so based on your skills and based on their availability, you will be given the opportunity in either of these three categories. So whatever it is, mostly design and verification go together. That means design engineer and verification engineer. Okay, basically when you are a design engineer, you should have a complete knowledge in and out in Verilog. Okay, and when you want to be a good verification engineer, you have to have complete skills on system Verilog and universal verification methodology. Okay, so apart from this, what are the skills you need to have means, there is nothing apart from this. You need to have some basic skills on where, since you are if you are having a knowledge on Verilog only, you can continue in system Verilog and UVM. Also along with system Verilog and UVM, you should also know some basic protocols also, like APB, AXI. Okay, you don't need to know in deep about these protocols if you are a fresher. You just need to know what is what on these protocols. Okay, hope you got the answer about this. Okay, and the next question is asked by Revati. Okay, is Verilog, System Verilog, and UVM courses easy to learn for an average student? Okay, this is also the most frequently asked question to me from so many days. I'm thinking to explain about this question. Okay, about explain more detail about this issue. Basically, when you're following me LinkedIn, I also told you that either it is easy or tough. Okay, it is all based on your state of mind. So why I'm stating it is state of your mind means, because basically when you are from engineering background, okay, and in engineering if you are an ECE or triple student, then since in engineering you already are familiar with certain subjects like digital electronics and Verilog. Okay, so in that case, system Verilog and UVM courses are easy to learn. That means you can start from there. Okay, but you are an engineering, mechanical, or CSE student. Even CSE student also, they will have digital electronics. Okay, which is of course the basic for every VLSI course. Okay, so that is why if you are based on at what position you are, okay, it seems to be an easy or tough case for you, because even though it is a CSC or IT student, you will be familiar of certain languages like C, CPP, Java. Okay, so any language basically in this VLSI like Verilog, System Verilog, and UVM, it is having some concepts that was taken from these languages like C, CPP, and Java. So that is why I am saying that based on your standout, it can be easy or tough for you. But with your hard work and with your consistency, any language will be easy or tough based on your state of mind. If you really like that particular course and if you want to learn it, then it will be very easy for you. Okay, so Govind Achari is asking that can we learn a Verilog course in one day? Okay, so the answer for this is, if you are really familiar with some languages like C, C++, or any language, okay, just for awareness I'm telling that if you are familiar with C++ and at least you have learned at some point of time, you know what is Verilog and what are the things that is there in Verilog, then you could do it in one day. But still, it is just a knowledge. Okay, it's not just the entire thing. That means you can just brush your skills in one day in Verilog, but you can't learn any course in one day. To my knowledge, any course needs to be given stipulated time in order to enter into it, and in order to know completely full version of the course will be learned only when you are given that particular course a stipulated amount of time. Okay, but if you already know it, and if you want to just brush up this knowledge, the brush up that particular course, and if you want to improve your skills, then it is fine for one day. Okay, but if you are new, if you are just learning alphabets in that course, then according to me it is highly impossible in one day. Clear? Yes, right? So this is about your question. Hope you got the answer for this. And then Mallika is asking that do we need to know protocols as a fresher to crack interviews? Yes, this is one interesting question here, because basically when you are a fresher, that means fresher means either final year student, is it or not, or a 1 year after final year. Okay, so those are considered as freshers. Basically when you are a fresher, okay, you need to have knowledge on particular concepts like system. When you want to enter into design and verification domain in VLSI, you need to know digital electronics, okay, and Verilog, system Verilog, UVM. Okay, along with it, you should know some basics in these protocols, like in AXI, mainly APB, EHB, and AXI. Okay, mostly APB and AXI. But in APB and AXI, they won't ask you any hands-on experience on these protocols, but they will ask you what is what. They just want to know whether you have at least a basic knowledge on that these protocols will be having, and what are the things that you will be having in these protocols. Okay, so that is the thing about this. So as a fresher, you don't need to know everything, and everyone don't expect you everything you want, that you need to know everything. But what you know it in a deep manner. That means mostly everyone, when you are a fresher, everyone expect you that you should have a knowledge on Verilog, system Verilog, and UVM, and some basic skills, okay, like communication, other things like, okay, apart further technical things, they will expect you to know a knowledge, to have a deep knowledge on digital electronic system Verilog, and UVM. Okay, but for these four concepts you should know them deeply, not in a basic way. Like you should know how to at least write a basic program, or at least write a basic test bin structure, or what is there in that test bin structure, what is the use of mailbox, or how do why do we use assertions, and what is the need of coverage. Okay, so at least they will expect you these things from thing. And as for protocols, they just want you to know just the basics of what are these protocols and all. Okay, hope you got the answer. And then Vardhan is asking that what are the basics we need to know before learning verification course. Okay, this is also most frequently asked question to me. Like either, as I think I already answered this question before itself, like if you are interested in design and verification domain, you should definitely know the concepts of digital electronics. Digital electronics is the core of all these things, because why I am saying that digital electronics is very important is because if you don't know how to generate, how to write, if you don't know the particular flip flop, or what is the use, what is the functioning of that flip flop, how can you convert from one flip flop to another, and what is asynchronous circuit, what is a synchronous circuit, and what is the use of clock. So if you don't know all these things, then if, even though you could learn the Verilog, system Verilog, and UVM courses, you could never put it into action. Okay. When you are into design, you should write a code, and when you are into verification, you should debug that code. Okay, for both this debugging and bugging, for both this writing and debugging skills, you need to know what is what. You need to know the basics. Basics are really important. Okay, so when you want to enter into either design or verification course, you should have command on digital electronics, Verilog, system Verilog, and universal verification methodology, along with some basic protocols. Clear? And then Prem Pujit is asking that what is the difference between design and verification domain? Do we need to learn SV and UVM if we want to be a design engineer? Yes, this is also one interesting question, because mostly many of you who are a fresher want to enter into design domain or verification domain, but you don't know clearly what does this design engineer do, or what does this verification engineer do. So today let me explain it in a small simple language that you could reach out. Okay, so basically when I have explained you in the starting itself, like in the VLSI like a VLSI design flow, there I have told you when a particular design need to be when a particular circuit or design need to be designed, first everyone will have its specifications. Like, what are specifications? Specification is nothing but for the particular design you want to design, it needs to have certain conditions, it needs to meet certain conditions, it need to work on certain conditions. So all these things will be given in the specification. So based on the specifications and based on rules, specification is nothing but some rules and regulations in order to design, like how my design should work, and what should be my design's inputs, and what is the output that I'm expecting. So this entire thing is covered in the specifications. So now what happens means, this specifications is taken by the design engineer, and he will be writing the code that is called as RTL code. RTL code means register transfer level code. So what is happening here is, this RTL code is written by the design engineer. Okay, so the design engineer will be writing a HDL code. Okay, it's based by using either Verilog or VHDL. Okay, he will be writing the code. Code is nothing but the logic for your entire design. He will be writing the code. Okay, now what happens after writing this code, the design engineer will be the verification engineer will be bugging this particular code. That means he will be verifying if this particular code is working on the given inputs, and is it producing the expected outputs. So all this verification, if it is not producing the expected outputs, then where is the bug? What is the reason? Why is it not producing the input? Like, why is it not producing the expected output? So all these things he will be verifying. Okay, so after verification, then it will be going to the simulation. Okay, that is another category. So when it comes to design and verification, the design engineer, since he is writing the RTL code by using either HDLs, either Verilog HDL or VHDL, so he should have a complete grip on Verilog. Okay, in Verilog, what you need to know? In Verilog, okay, in Verilog, you need to know everything regarding what is a module, or what is module instantiation, what are functions, how can you use functions, or how can you use this task, how can you use system tasks. So how can you use all the things, like entire Verilog you should have, along with along with Verilog, you need to know this digital electronics also. Okay, so whatever you're going to design, everything is based on digital, is it or not? So you should have the entire grip on digital electronics, like combination and sequential circuits and everything, and then you should have a grip on Verilog. Okay, but if you are a verification engineer, you should know system Verilog, UVM along with Verilog. Because if you don't know Verilog, you can't go for system Verilog. Why is? Because system Verilog is the advanced version of Verilog. If you don't know ABC and you are going for writing the letters, it is not a proper way, is it or not? In the same way, if you don't know Verilog, you can't jump to the system Verilog. So that is why a verification engineer should learn both Verilog, system Verilog and system Verilog. Okay. Hope you got the answer for this. What is the difference between design and verification, and do we need to learn SVUVM if you want to be a design engineer? Got it? And then Kalpana is asking, can you suggest some sources where we could get to know these courses? Yes, sure. So basically, when you are learning some course and you when want to learn furthermore on that course, okay, I'll be suggesting some websites like chip verify. Okay, if you are having LRM, okay, learn if you are having Verilog LRM, then it is fine, that is more than enough for you. But along with LRM, if you want to if you want to search some more websites, then you can go for chip verify, CHIPVERIFY, chip verify. Okay, VLSI verify, VLSI verify, VERIFY. Okay, so these are the most important websites, like if you want to learn Verilog. And when it comes to system Verilog and UVM, you can go for verification guide. Okay, so these are some of the most frequently used websites. Even though if it's me or any other person who is related to this design and verification, everyone will be checking mostly these four sites. So one is chip verify, another is VLSI verify, one is verification guide, and the last one is ASIC world. Okay, ASICWORLD. Okay, you can check any of these websites. Clear? Right? So this is all about today's doubt clarifying session. For the next session, I'll be getting to you some more important questions and some more most frequently asked questions to me. Okay, so that is all for today. Thank you.